Generally, when you launch Unity, this is the screen you're going to see, this little box. So we're going to click New to start a brand new project. Oh, there we go. And first of all, we're going to change the template to 2D. So Space Invaders is a two-dimensional project. We're only operating in X, Y, although you will see that in Unity, even if you're operating within a 2D environment, you still have the Z coordinate available to you. It's just set to 0 by default. So we're going to switch to 2D template and then name your project, Space Invaders. I'm going to name mine 2.0 because I already have one version. So basically, whenever you're naming Unity projects, spaces don't matter. It's not like naming variables, so you can pretty much do anything you want. And then I'm going to hit Create Project. And then when my default project opens up, hopefully sometime today, hurry up, Unity is loading, faster. Is he gonna make it? I'm taking bets.
I got it. Okay, we're good.
Oh, I was betting against it. Okay, so Unity launched, and if you look at the top corner right here, there is a little tab called Layout. So I tend to use, so most of you, if you've never used Unity before, it will come up looking like this. This is the default layout. I generally don't like this layout for several reasons. So I do, I think the one that I do is 4 split. Nope, not the, which one do I do? 2x3. Yeah, there we go. So 2x3 is the layout that I normally use. And the reason for that is because whenever I design something, so this is essentially your design space. This is where you place all of your components, all of your sprites, or all of your 3D objects if you're working in a 3D template. This is what your environment is going to look like in the actual game. So this is giving you the live preview. So for example, if you're working in Unity 3D, designing a 3D game, and you're manipulating the camera to see, like if you move the camera, what this scene is going to look like. So you can see in real time what this scene is going to be like, right here, unless you're loading objects procedurally. So having these two things on the screen at the same time is really helpful. Then this part on this side, this is where your project hierarchy is. So any asset that you add, any game object that you add, and by the way, almost everything in Unity is a game object. We'll talk about that in a little bit. So all the components that become part of your scene, they get listed here, and they're organized in a hierarchical fashion. So for those of you who are Windows users, think Windows Explorer, the way files are organized into folders and individual files and subfolders. Or if you're a Mac person, think about Finder. So this is essentially the same thing. Then the actual assets, the actual files, not game object, but the actual files, they are located under assets. So if we go into the actual Unity project, so I'm going to open it in Finder. Finder. All right, so if I look at my project, you will see that there's a subfolder called Assets right here. And if I go into it, all the folders that you see in Unity, that you see right here, they will be reflected in that Assets subfolder. So generally, it's not a good idea to add files directly into a Unity project through the file system. Most of the time, Unity will recognize it, but sometimes there's weirdness. So whenever you add assets into Unity, it's better to actually go through the Unity editor. So we're going to start by actually right-clicking on assets, and I'll talk about the inspector pane in a little bit. And we're going to create a bunch of new folders. So let me zoom in a little bit so you guys can see this a little better. So we already have a folder called Scenes. I'm going to create a folder and call it Sprites. scripts, and and sounds. And finally, the last folder, and that one doesn't start with the letter S, we're going to call it prefabs. So generally, whenever I start a project, this is one of the first things that I do. I try to keep my projects organized because with Unity, it's very, very easy for a project to get out of hand because you're not just dealing with code like you would with, let's say, an Eclipse project or just a regular Visual Studio project. You're also dealing with a lot of external libraries. You're dealing with a lot of scenes. You're dealing with graphical, audio, video assets. So you have a lot of stuff that you have to manage. So it's generally a good idea just to start organized. So your scenes obviously go into the scenes folder. So each scene corresponds usually to a level in the game. If you want to think about it like that. All the programs that we write, all the scripts, C# scripts that we write that are going to be attached to our game objects, they're going to go into scripts, sounds into sounds, and so on and so forth. So let's actually start with our sprites folder. So I'm going to open up my sprites folder and then just find, I should have downloaded it, but I think I still have it somewhere. Do as I say, not as I do. All right, so we'll go into my Google Drive folder, and I'm going to grab my sprites. I'm going to open it, and I'm going to take all 3 sprites. So you can see that I have 3 sprites in here: alien.png, bullet.png, and ship.png. Select all of them and drag them into the sprites folder. And then I'm going to do the same thing with sounds. I'm going to go into the sounds folder, and even though we're not going to use sounds right off the bat, I'm going to download sounds anyway. Download them. Unzip them. And put the files into the sounds folder. One of the sounds folder files is pretty large. I didn't have time to downsize it, so I'd like to apologize for that. So it might take a second or two to load. So now that I actually have all the stuff loaded into my project, we can start building our game. So is everyone at this point? All right. If anybody is running behind, please stop me. We'll help you. I want to make sure that everybody is on the same page. So the first thing we're going to do is we're going to rename our scene because we don't want our main scene to be called sample scene. So you can right-click on it, or actually not right-click on it, but if you click, it's not going to let me rename it in here, is it? Because it's a folder. All right, we'll go into scenes and right-click on the scene here and go to rename. And I'm going to call it level 1. And it's going to rename it in my hierarchy. So the first thing we want to do is we want to add a spaceship. We're going to start by adding spaceship. So we're going to take it piece by piece. There are a couple of ways we can do this. So let's kind of think about this logically a little bit. So what do we need for the spaceship to do? So it needs to move, and it needs to shoot. So we'll start by moving it first, by getting it to move. So adding a component into the hierarchy is pretty easy. So I'm going to start with sprites. I'll go into the sprites folder, and I'm going to click on my ship sprite, and I'm just going to drag it into my scene and let it go. And you will notice that as soon as I let it go, I have a component added into my hierarchy. Now, here's one important distinction. In this folder, we have a sprite. A sprite is a two-dimensional graphic. As soon as you added that sprite to a scene, it became a game object. So in your list of folders right here, it's a graphic. But right here, it's a game object that has a lot of properties associated with it. So for example, if I click on it and select it, let's look at some of the properties. So we'll look at the final pane called the inspector. And if we look at it, we're going to see a bunch of information about this game object. So first of all, every game object in Unity has a transform. A transform defines the object's position in a three-dimensional space. Because we're dealing with two-dimensional space, it's simply ignoring the z-coordinate. So in here we have its position as an x, y, and z. We have its rotation, and we have its scale. So what scale allows us to do, it allows us to make an object smaller or larger. Just to show you, if I set x to 2, for example, you can see that it'll stretch the sprite on the screen. So you can use scale with Unity primitives. You can use scale with vector graphics. Because I'm using pixel art, which is rasterized, it's not a good idea to scale it up. It's just going to look like garbage. So now that we have the first sprite, let's first of all rename it. And I'm going to rename this into player. So I'm going to call this whole thing player. And note that the general convention for Unity development and for C#, just like with Java, object names are capitalized. So the object that basically contains my ship, I'm calling it player with a capital P. Everywhere in code, I'm going to reference it by its name as player. Another thing, if we look at the inspector, that's kind of very important to remember, is the idea of tags. So idea of tags in Unity is critically important if you're dealing with multiple objects that are interacting. So for example, in this game, what do we have? We have a player, that's the spaceship, and then we have a bunch of other things. So what are some of the other things we have in the game? Right, we have aliens. How many aliens are we going to have? One or many? Many, right? We're going to have a bunch of aliens. So instead of me, let's say when I shoot an alien and we detect the collision between the alien and the bullet, instead of me writing a really long if-else statement saying, if I hit alien 1, do this, or if I hit alien 2, do this, it's a lot easier for me to tag all aliens with one tag that basically groups them together. So then if I detect a collision with an object, I can say, if this object has a tag of alien, you can act on it. So it reduces the amount of if-else statements we have to write. So I'm going to click on my tag. And in this particular case, so these tags are available by default. So there's already a tag called player. So I'm going to assign this tag to my player. But also, while I'm here, I'm going to add a tag by clicking the plus sign. And I'm going to create a tag called alien. And I'm going to create another tag called bullet. Since we're here, we might as well just do this. And then I'm going to hit save. So Command S or Control S, Unity is very, very stable. In like the last 4 or 5 years that I've developed in Unity, I think I had it crash twice, and it was mostly my fault. But still a good idea to save often. All right, so now we have this game object. There are a couple of ways. Well, first of all, actually, let's make one more change, and we're going to make a change to the scene itself. So in the original game, the scene, the background is black. It's not white. So we want to stay as true to the original game as possible. So I'm going to click on level 1. and I'm going to click on main camera. And then with main camera, let me zoom in a little bit so you guys can see better. I'm going to click on the background color. And usually, for some reason, it pops up the color selector here. And I'm going to just set the hexadecimal value to 0. So doing that makes my scene completely black. So now I have an alien on I have a spaceship on a black background. So the first step we want to take is we want to make it move. And there's a bunch of different ways to make something move in Unity. The most, I guess, one of the easiest ways to do it is by assigning arrow keys to actions. So we're going to start by creating a script. And the way you create a script, so first of all, everything in Unity is an object. And when you add a component to an object, that component is also an object. So essentially, you end up with like this hierarchy of nested objects. So if we look at player again for a second, so let me click on player, you will see that transform is an object in and of itself that has properties of position, rotation, and scale. And then position is an object as well that has 3 properties, X, Y, and Z. Sprite render is an object that has a bunch of properties. So what we're going to do is we're going to click Add Component. And the component that we're going to add, so first of all, when you click Add Component for the first time, you see a bunch of stuff here. We're going to look at very few of these things today. It takes years to learn all of this. The thing that we want to create right now is a new script. And generally, the conventions in Unity when you name scripts, so I have an object called player. If the script that I'm creating is to move the player, then I'm creating something to control the player. So then I'm going to name my script player controller. When I create a script for bullet, I don't control the bullet. The bullet flies, in a straight path essentially. So I'm going to create a script called bullet behavior. So kind of like all scripts start with the name of the game object to which the script belongs, and then the second part of the name needs to be descriptive. So I'm going to name this one player controller. And I'm going to hit create and add. So Unity, whenever you add any type of external component, by default, Unity places it at the root of the assets folder. So just to kind of keep everything clean, I'm going to take the script and I'm going to drag it into my scripts folder. And go into scripts. So once my script is organized and once it's here, I'm going to double click it. Scripts are edited outside of Unity. They're C# programs. And so depending on what kind of setup you did, if you are on Windows, most likely double clicking on the script will launch Visual Studio. If you're on the Mac, unless you actually explicitly installed Visual Studio, most likely it'll launch MonoDevelop, which is just a C# development environment for Macs and Linux. I'm using Visual Studio for almost everything nowadays, so makes things a little easier for me. So I'm gonna give everybody a couple of minutes or a couple of seconds, make sure everybody has their script editor launched. And let me know if you have any problems launching your script editor. Austin, can you?
Actually, right. That is one of the very first ones. So you put it under apps. Click on that. See how there's a component? That's just the game. So, good. What are we naming this script?
Player controller. Oh yeah. Let me,
Some kids came in late.
Really annoying.
I'll leave it up for a moment.
Ours would literally just ships me to like 3 blocks. You get a 20 minutes or forever. Yeah, it was like they're just had the assets ready. Like, oh, what? It's such a pain. Oh, yeah. Well, that some changes. Are you a freshman or sophomore? Freshman. Sophomore. So your science tickets. What class taking so far?
Cool. So now that we launched our script editing environment, let's take a look. Let me see if I can actually just make the fonts bigger. Remember there was a shortcut for it, but there we go. All right, cool. So by default, any Unity script that you create, well, first of all, it's a class. C# is an object-oriented programming language. But if you are not familiar with C#, but for example, if you're familiar with Java, you may notice this colon sign here. So what that means is that player controller, the class that we just created, it inherits from mono behavior. So all it is, it's an inheritance symbol. And you will see that most classes by default that you create, they will inherit from mono behavior until you start getting into kind of like more higher level development. By default, you will also see that there are 2 methods or 2 functions that are generated for you. Every Unity script has a life cycle. The first event that fires in a life cycle, it's called event. It's called awake. Essentially, that's when the object gets loaded into memory. When the object gets added to the scene, the event that gets fired or the method that gets fired is the start method. And the update method, it gets called on every frame. So for example, you can think about a video game as a movie. And for a human eye to actually kind of like get the sense of motion and everything, you need to run your motion at least 24 frames per second. So for example, if your project is set to run at 24 frames per second, then every second the update function is going to be triggered 24 times. Does that make sense? So it's basically it's triggered by the frame rate, and we're gonna kind of utilize that a little bit. So the first thing we want to do is we want to detect when to move, or we want to decide when to move our script. Before we really get into moving our object, I want to show you something that kind of becomes very important and for some people very confusing later on in Unity. So I'm going to create a public variable, public float, and I'm going to call it speed. And I'm going to initialize it to 1f. So first of all, any floating point variable in C# has to have a suffix of f, so the numbers followed by letter f. By default, variables and methods in C# are private. So let me actually, for a second, remove the public modifier. And let's go back and look at our player object in Unity. So first of all, notice that we added a script component called player controller. So we added a script. That script is now a child of the player object, and it's an object in and of itself, and it can control some of the behaviors of that object. So any component that we add to a game object becomes available to you for editing in the inspector pane. So notice that right now the script player controller doesn't really have anything that we can modify in the inspector. However, if I go back here and if I make this variable public and resave it, it becomes, usually takes a second, it becomes available to me in the inspector. One of the reasons why this is so important is that, first of all, it allows us, as we're going to see in a little bit, it allows us to link objects between different scripts. So it allows us to link game objects to scripts. We can basically drag and drop objects into public variables, but also we can modify. So for example, right now I'm developing my game, I'm testing it. I don't know if one is a good speed or if it's too slow or if it's too fast. So if I set it up as a private variable, then every time I would have to go back, change it, recompile it, and so on and so forth. By having it available to me in the inspector, I can just change its value and play with its value. And once I'm done developing, if I don't need it to be public, I can just change it back to private and just hard code it to whatever value makes sense. So for now, I'm going to leave it as public. I'm going to jump back into my script. I'm going to make it even bigger. And one more thing to kind of think about. So when we move an object, we're essentially changing its position in 3D space. So its position is denoted by a three-dimensional vector that contains three components, x, y, and z. So there's a variable type, there's a data type in Unity called vector3. There's also vector2, and I think, what is it, up to vector 5? I don't remember exactly. So what we're going to do is we're going to create, actually we're not even going to create another function. So inside update, what we're going to do is we're going to create a vector3 variable. So it's up to vector 4 actually. So vector 3, and I'm going to call it move. And I'm going to instantiate it. Oh, let me actually comment this out for a second. We'll do one thing before. So we need to capture when the keys are pressed. And there are a couple of ways where you can capture key presses in Unity. So the easiest way to do this and the most common way to do this is there's a static class called input, and you can just call a method called getKey, and then, for example, key code.space, and this will give you when the space bar was pressed. So we're going to use this approach whenever we shoot. So space bar will shoot. So we'll come back to this. Or you could do, left arrow, right? So we could write basically if input.getKey left arrow, then do something, right? The problem with this approach is, what if you're trying to design your game that it works across multiple platforms, including mobile platforms? So an iPad doesn't have arrows, so there's nothing to capture. So generally, whenever I design things like this, I really try to think about where this game could possibly go, and also I want to try to avoid writing 50,000 if-else statements. So what we're going to do instead is we're going to define a floating point variable called h, because I don't like typing. So h is going to stand for horizontal motion. And then we're going to define one called v for vertical motion. And h is going to be set to input.getAxis horizontal. So basically, if you're using an iPad, then this code will use input from the accelerometer when you tilt it. If you're using a keyboard, it'll essentially recognize arrow keys, so left and right arrow key, as either a positive or negative horizontal motion. And we can do the same thing for our vertical motion. And do this. So this will give us two floating point values. And again, because we're getting those values in the update function, we'll get them often enough, so we will get them 24 times per second, so that the motion is going to be pretty seamless. So finally, once we have this, we can actually go back and uncomment our vector. And the vector 3, to create a new vector 3, we need 3 values, x, y, and z in this particular case. So our x value is going to be h, that's our horizontal movement. Our y value is going to be v, our vertical movement, and we don't have a z, so we're going to put 0f. Remember that f because we're dealing with a floating point number. If you don't, it's going to get really weird. All right, so now that we basically figured out the vector change for our motion, the next thing we want to do is assign that delta change to our game object, in our case player. So because this script is a child of the player object, it already knows who its parent is. So implicitly, we have a variable called game object available to us. So in Unity, whenever you see game object with a lowercase g, you're referencing the current object to which the script belongs, in this case player. You can also instantiate other game objects. So whenever you see game object with a capital G, you're referencing another class. Does that make sense? So that's a difference between a class, for those of you who are familiar with object-oriented programming, and an instance of a class. So whenever you see lowercase g game object, it's referencing the current instance of that game object. So right now, by default, the player object is available to me. So all I have to do now is change its transform. So again, if we look at the inspector for a second, you see that every game object has a transform property. So I can just say gameObject.transform dot position. And the IntelliSense in Visual Studio is really, really good. It'll give you hints. So the position is a 3D vector, or a vector with 3 components, x, y, and z. So I'm just going to add to it. So plus equals means I'm adding to itself. And I'm going to add the vector itself. And I'm going to add motion speed. And the next piece that I'm going to add, I'm sorry, not add, but multiply. So motion times speed times, what I want to do is I want to smooth out the motion. So let's actually see if I leave it like this and go back. So one of the things that's kind of helpful, if you're working with a very large scene, there's a button here called Maximize on Play. So if that button is checked, what's going to happen is your game preview is going to go full screen when you hit play. So I'm going to do that. I'm going to hit Maximize on Play, and I'm going to hit the play button. So you'll notice that mine turned this purplish color. Yours probably didn't. I'll explain in a second why that is. So here's my alien. It's kind of moving insanely fast. It's difficult to control. So to smooth out the motion, what I'm going to do is I'm going to also multiply it by delta time. essentially it multiplies it by the time, what is it? Pat or Austin, do you remember what delta time references? Is it the time elapsed between frames or between each update?
It's time between frames.
Between frames, okay.
Because updates the same amount as frames.
Okay, thank you. So basically, if you want to look at the difference now, now it's a lot more reasonable. So now it's moving a little slower. It's a little too slow for my taste. So this is where I'm going to go and adjust the speed and maybe set it to 3 and run my game again. And now it's moving a little faster. So this is more reasonable. Maybe for game purposes, I'll change this to 5. And play again. Okay, I like this. This is good enough. So let me tell you why my screen turns purple and yours doesn't. One of the things that just absolutely drives me nuts about Unity, and they did it for a very good reason, but it still drives me nuts. So while you are in play mode, while you're testing your game, so I unchecked maximize on play, I'm gonna hit this. So now you can see that I can observe how things are changing in my scene. The thing is, while I am in play mode, if I make any changes to my scene or to any of my objects, as soon as I exit the play mode, those changes are gone. So Unity does not save changes that you make while you are in play mode. And this is something really important to remember because I cannot tell you how many times I screwed things up by basically like adding a bunch of colliders, adding a rigid body, modifying a bunch of components, and then realizing that I'm in player mode and going, oh shit, I just lost like half an hour worth of work. So as a reminder to myself, if you go to Unity and go to Preferences, one of the options that you have under Colors is Play Mode Tint. So whenever I set up Unity on a new computer, this is literally the first thing that I do. I set a play mode tint to some obnoxious color so that whenever I'm in play mode, I actually know that I'm in play mode and that any changes that I make to my scene are not going to be saved. So just to give you an example, so let's say I'm in play mode now, and I go and I change my speed to 10. Now it's moving a lot faster. As soon as I exit play mode, it reverted back to 5. So any changes that you make in Unity while you're in play mode are gone as soon as you exit play mode.
What about the actual code?
The script, it doesn't affect scripts. Thank you for bringing that up. So because you're making changes to scripts in a separate editor, it doesn't matter if you're so if you make changes to a script while you're in play mode, those changes are not going to be immediately effective. You need to stop and then hit play again so that the scripts essentially will reload. But none of your changes are going to be lost. It only applies to Unity editor itself. All right, cool. Thank you, Dan. All right, so now we have our amazing spaceship and it moves. Is everybody at this point? Okay, I'm gonna pause and we'll get everyone caught up. So now we basically have the first element of our game, and that element is and that element is the ability to move our spaceship. Are you guys okay? Do you want me to wait for a minute? Okay. I see a thumbs up from Dan, so we'll keep going. All right, so let's get one more piece or one more component added to our spaceship, and that component is a collider. So remember, the game mechanic basically requires us to detect collisions between spaceship and aliens, and between bullets and aliens. We don't care about collisions between the spaceship and bullets. So we're gonna select our player, and then in the inspector, I'm gonna go to Add Component, Physics 2D, because again, we're dealing with two-dimensional space. And let's look at the shape of our spaceship for a second. So it has like this really weird, uneven shape. And if you look at the selections of colliders that are available to you, so we have a box collider, we have a capsule collider, a circle collider, and then we have something called an edge collider. So if you select an edge collider, what basically Unity is going to try to do, it's going to try to draw an exact edge around your object and try to detect collision around that edge. That being said, if you think about the game mechanics, we only care about front collision here, right? And if we choose an edge collider that's going to precisely wrap around our spaceship, it's going to be pretty expensive computationally, because then Unity is going to have to basically watch every single edge of that collider. So we don't want a complicated shape. So what I'm going to do here, I'm going to choose a box collider 2D. And here's another shortcut that I want to show you. The shortcut will save your sanity one day. Basically, as you're working in Unity, the more objects you have and the larger the scene, the more difficult it becomes to figure out where those objects are. So if you select an object in your hierarchy and then move your mouse into the scene and hit letter F, it'll zoom in on that object. It's one of the most useful shortcuts that I've dealt with. So if we look at our object, you can see that there is a thin green box around it. So that box is our collider. So essentially anything that touches that box can trigger a collision. So that's how Unity knows when two objects try to occupy the same space. One of the things that we want to do, because we're dealing with a 2D world, we don't really care about physics. We're going to set this collider as trigger. So there's an option called is trigger. So essentially what we don't want to have, we don't want, when two objects collide, we don't want them bouncing around, and we don't want them to be affected by physics. So this collider, we have, yes, sorry.
Slow down a little bit.
Okay.
You're trying so hard to follow.
My apologies.
No problem.
Okay. All right, so we added a collider, and we're going to pause here. All right, so we created a trigger. So for now, we're done, at least for a little bit, we're done with our player object. We'll come back to the player object shortly. So let's create a new object. We're going to jump back into sprites, and we're going to create an object called alien. And I'm going to take the sprite and drag it into my scene. So first of all, before I drag it, you'll notice that the alien is zoomed in. I don't like that. So if you scroll, or on a Mac, it's like the two-fingered scroll over your scene, you can zoom in and zoom out. If you're using an external mouse, you can probably use the little scroll wheel. You can also reposition your scene. So at the top, there is a hand tool. If you click it, it allows you to kind of reposition your scene, just to make it a little easier to see. So now that I see my entire scene, I'm going to take alien and I'm going to drop it into the scene. Because I'm testing things, I actually want to drop it fairly close to the spaceship, so I don't have to move things a lot. And we'll reposition it later. One thing that I want to tell you, again, because as you're developing, conventions will become very important. If you right-click on alien and go to rename, come on, rename, you can do this. Change it to an alien with a capital A, so we stay consistent. All right, now that I have my alien, the next thing I'm going to do, and again, remember, so we have multiple aliens. we want them all to be grouped together by a tag. So remember we talked about tags at the beginning. So with alien selected, I'm going to my inspector, and I'm going to assign my alien object the tag of alien. And again, save. Make sure you save everything. So now I have an alien. The first thing I'm going to do to my alien is give it two properties. The first property that I'm going to give it, it's called a rigid body property. The rigid body property basically enables physics. And in order for colliders to work, this is like one of those weird things in Unity. One of the objects that's tracking collision has to have physics enabled. So we're going to click on Add Component, Physics 2D, and you will see that somewhere in there's a component called Rigid Body 2D. We're going to select this component. And what I want to do is I want to run the game now and show you something. So watch the alien very closely on the screen. As soon as I run my game, my alien falls off the screen. So let's do this again with screen maximized. So it falls down. The reason it falls down is because we enabled physics on it. Because we're dealing with a two-dimensional space, on the y-axis, minus y is actually considered as down. So gravity is enabled. Because we enabled physics, it falls down. We don't want them to fall down. So what I'm going to do is I'm going to go back into my inspector, and you will see there's a value called gravity scale. By default, it's set to 1. I'm going to set it to 0. And now, if I play one more time, you will see that the alien will stay where we intended it to stay. So it sits in place, doesn't move. That's what we want. All right. Everybody has their alien and their rigid body. Cool. We're also going to add a collider to it. So just like we did with the spaceship, with the alien selected, I'm going to go to Add Component, Physics 2D, and I'm also going to add a box collider just for simplicity's sake. So box collider 2D. It's going to put a little green box around my alien. And don't forget, you need to enable isTrigger. Okay. So now what we want to do, we want to set up a mechanic that if our player touches the alien, the player dies, because that's part of the game mechanic. So right now, if we play the game, and if I move my alien, or if I move my spaceship, it just flies through the alien. What I want is I want the spaceship to be destroyed as soon as it touches the alien. And this is super, super simple to do. Because both of them have colliders, and because alien has physics enabled, where do you think, so who do you think should have the on collision destroy behavior? The alien or the spaceship? Why do you think it's the spaceship? Okay. Both. You can do both? Yeah. But why? Chaos. Chaos. Okay. The spaceship is being destroyed. So basically, I would agree with you. From Unity standpoint, it doesn't really matter. From good software development standpoint, we should assign that behavior to the player because the player is the one who is being destroyed. So what we're going to do is we're going to go back into our player script, and we're going to add one more function to it, one more method. And that method is, so it's a void method. Capitalization is very important, so it's not just a convention, it's part of Unity API. Unlike Java, where methods are, the first word of a method is lowercase. In C#, it's a convention that everything is capitalized. So this particular method is called onTrigger enter 2D. So this is what you need. And on trigger enter 2D is essentially an event listener. Can anybody tell me what an event listener is?
When something happens, it executes something.
Yeah, it just sits there, waits for something to happen. In this particular case, it waits for any trigger, anything with a trigger to collide with this object. In this case, it's the player. And the parameter that it passes into the method is the collider of whatever object collides with our player. So it's the other collider. Does that make sense? So for example, if the player collides with another alien, this collision variable contains the collider object of the alien game object. It gets a little complicated. Okay, so let's actually, first of all, one of the things that I like to do is I like to debug things a lot to make sure that they work. So in Unity, there's a console to which you can write out text messages. The way you write out messages to the console is by calling debug.log, and I'm just going to write collision. So before I do anything else, I want to make sure that it actually captures the collision. And save, make sure you save. I'm going to go to Window. And in Window, I'm going to go under General and Console. And it's going to open the little developer console. You can also hit Command-Shift-C, I think, and it'll do the same thing. So now let me run my game.
Wait, can you go back to the code?
What?
What was the last thing you typed?
Oh. So if I run this, and if I did everything correctly, if you look at the console, as soon as the alien touches the spaceship, you can see that the word collision is written out to the console. So it detected that the two objects are touching. Yep.
So is this method only like executed when sort of like their boxes intersect?
Exactly.
It's reset once they leave each other?
Yes. So every time, you're absolutely right. So it doesn't reset per se, but so every time they touch, it's going to detect a collision.
What would the method be if we wanted to detect it like every frame? Would we just put it in update or put some code?
So you can't really put it in update. If you wanted to detect whether like they're constantly, if they still occupy the same space, you would basically need to create a global variable and like set it to true when the collision occurred first time, and then check if it's still true in the update. But because the onTrigger enter is its own method, it's part of Unity API, you can't put a method inside a method.
Isn't there on-trigger overlap or something like that? I think
I don't remember, but it may address that.
Yeah, there's on-trigger enter, on-trigger exit, and then on-trigger state.
Yeah, on trigger state.
OnTrigger stay, yeah, that's it. That's what it is. I've been doing it the hard way.
But remember, whenever you do that, it's calling that every single time. That's hammering. So if you instantiate like 1,000 freaking objects, and you're just on trigger stay, you're gonna get success. So a good practice is you want the least amount of code in your update. You guys aren't at that like level where you're like building these huge grand games, but it's good. Just keep that in the back of your head. When it's in update, it's executed every single time.
Yeah, that's a very good advice. And with games, especially, the more assets you have, the more critical it becomes.
Do you know, is the granularity of on collision, do you know if that is on fixed update or on update?
I don't remember. So a lot more. I think it's actually on fixed update, if I remember correctly. But I didn't really, I don't know if I
Yeah,
should
I
get
couldn't
into the
agree either.
difference between fixed update and update right now.
So there's two updates. There's update, and that's just running, and that's inconsistent. Okay, that's just running whatever, that's allocating memory and using as much as it can whenever it can. Then there's fixed update, that's for physics, and that's a fixed incremental time. So you'll have a more consistent physics response when you're pushing something.
So
that
it's
physics
like
always
if
does
you have
update.
24 frames per second rate, it will update like every 1/24th of a second, exactly, the same interval.
So you won't get, if you're pushing it with physics, it won't be like, whoa.
So if you're using update, it'll still run 24 times per second, but it will not run on precise intervals, basically. Yeah.
I mean, is there a way to tell, or when the collision object is called, it was saying that it's referencing the alien collision box. Is there any way to figure out which?
Oh yeah, absolutely. So that's the next thing I'm going to show you. So now that we got to the point where we know that we can detect collision, so what I'm going to do is I'm going to say if collision. So collision is the variable that gets passed into our function dot game object. So I'm referencing the parent game object of whatever object I collided with dot tag. So that's why we want to tag our objects. So if it's equal to alien, I'm going to call another function called destroy. Or I can do destroy this. It'll do the same thing. So essentially what this logic does, I'm checking if whatever object, so this script right now belongs to the player, to the ship. So what I'm doing is I'm checking if I collided with an object, any object that has a tag of alien. And if that happens, then the current object gets destroyed. So let's see if we did this right. That's it. So let's maximize this so everybody can see. So as soon as my spaceship touches the alien, it'll disappear off the screen. So it's destroyed. I know my logic is good. My logic is solid. So what I'm going to do next, just because we want to continue testing things and continue building things, I'm going to select my player object. And you will see that in your scene, you have the arrow keys here. Whenever you click arrow keys, you get two handles, one for X and one for Y. If you're in three-dimensional space, you have X, Y, and Z, and this allows you to reposition your object. So I'm just going to move my object along the Y-axis to the bottom of the screen for now. Okay. So the next piece that we want to do, the next part that we want to do, is we want our aliens to move on their own. And for simplicity's sake, because we're kind of a little bit short on time, and I don't want to get into designing logic where it detects boundaries of the screen. So for simplicity's sake, we're going to say we're going to set up our aliens to move 5 points in each direction, or something like that. 5 moves in each direction, then move down, reverse, 5 moves, move down, reverse, and so on and so forth. So just to simplify things a little bit, and make things kind of easier to manage. All right, so I'm going to create another script. I'm going to right-click on alien. Let me close the console for a second. And I'm going to go to add component, new script, and I'm going to name this alien behavior. And hit to create and add. So remember that scripts go into the root of assets. So I'm going to grab it and drag it back into sprites. I'm sorry, into scripts. And then double click alien behavior and open it. I'm gonna pause for a few minutes and let everybody catch up in an actual game. So the next step, now that colliding, we got part of the collision working, we want to give some limited intelligence to our aliens. And now we're going to make a few minor changes to the alien behavior script. Okay, so I'm going to create two variables, one public, one private, and I'll explain why in a second. So I know that some people in the back are having a hard time with the fonts. I know you can, it's not even letting me make it larger. Sorry, guys. I can make it smaller, but can't make it larger. Apparently, there is a limit. I mean, I could zoom in, but anyway. All right, so we're going to create a public float, and I'm going to call it move by. And this is going to determine by how many units we're going to move an alien at a time. And I'm just going to initialize it to 1F. And then the next one we're going to do is we're going to create a private variable, or we don't even have to declare it as private because it's private by default. And it's going to be int number of moves. And this one I'm going to initialize to 0. So as I said, move by will essentially allow us at runtime to see how far we want to move the alien with each jump, because remember, we want the jerky motion that exists in the original game when the aliens move a couple of spaces at a time. And then the reason we want to control number of moves is because in this particular implementation, we're just going to do very, very simple logic. So once they make 5 moves, let's say, they jump to the next line and reverse. 5 moves, jump to the next line and reverse. Okay, cool. So I'm going to create another, in this one, we're not going to need update, so I'm just going to delete update altogether. And I'm going to create another one, so this is going to be a custom. I'm going to call it change position. And change position is going to be pretty simple. So what I want to do is, first thing I want to do is I want to capture the alien's current position. And that's pretty easy to do. So position is vector 3. And I'm going to call it position. And I'm just going to reference the current game object, which is the current alien dot transform dot position. And this gives me the 3D vector that basically describes X, Y, and Z of the current position of my alien. And then I'm going to create a new variable. I'm going to call it new position because I'm creative like that. And this one I'm not going to, I'm declaring it but not instantiating it. So we have this variable. Now all we have to do is write a very simple if-else statement. So does everybody know what a modulus operator is? It gives you the remainder. So essentially, if we want to keep counting 5 moves, so whatever number of moves we have divided by 5, if the remainder is 0, then we're done moving in that direction and we need to reverse. So I'm going to do if number of moves modulus 5 equals to 0, excuse me, and number of moves is greater than 0. The reason we need that is because number of moves is initialized to 0. So 0 mod 5 is 0. We don't want it to try to reverse and jump down right when we start the game. So if that's the case, then we're going to initialize new position. I can't type today. I misspelled it, that's why. It's new position. So new position equals to new keyword, new, seriously? New vector 3. This was hard. So because we initially care only for position X, So we keep the original position X, and we add to it move by. So we know by how much it's gonna move. Then position Y minus. So we want to take an absolute value of, excuse me, move by, I think I did. And then we're going to do 0 for the z-axis. Else, we're going to do new position equals to new, again, I'm having trouble with new, vector 3, position dot x plus move by, so it always moves in a particular direction. And, excuse me, we leave position y and position z unmodified, or we could just set position z to 0f. And actually, this is something that I forgot to do above. This should be 0f, not 0. All right, so there's one piece that I missed, and that piece is, so basically whenever we make 5 moves, we need to reverse direction, right? Which means we need to change move by to move by times -1. So essentially, initially it moves in one direction, then reverses direction again. I'm going to leave this code up for a little while so that everybody can catch up. Let me actually hit enter here so it puts it on a new line so you guys can see better. And then the last piece that I'm going to do, in hindsight, this probably turned out to be more complicated than need to be. So game object.transform .position equals to new position, and we'll increment number of moves. So I'll run this to make sure that it works, and then I'll leave the script up so you guys can catch up. Oh, duh. Okay, so one thing that I forgot to do, something very important, in start, there's a very useful function called invoke repeating. And what that function does, it allows you to basically call another function on a timer. So invoke repeating takes the name of the function that you're calling. So in this case, it's change position. And then the first argument is time. We're going to ignore this argument. We're just going to care about repeat rate. And for us, repeat rate, so let's start with, I don't know, 1. So we'll try calling every 1 second and see how well it works. So the code kind of sucks. Please don't do this in real life. This is just quick and dirty, just to demonstrate a concept. It's what?
Like, you move like erratically, like.
It's a one-off error. So, but so let's maybe change this to 10, just to give it a little more latitude and motion. And in Unity, I'm just gonna take my alien game object, come on, and move it to the side of alien, and move it to the side of the screen so they kind of originate here. And test this one more time. So it moves. All right. So the next thing that I'm going to do, I'm gonna move it up too, so it starts a little higher. All right, so we'll start our aliens here. So let's learn one of the coolest concepts in Unity. But first, I'm gonna leave the code up for a little bit and let you guys catch up and test everything. Created essentially, an alien object, but it's a one-off. So what we want to do is we want to take that object with all of its properties, all the scripts associated with it, because sometimes you have very complex objects that consist of like an entire hierarchy. So for example, if I wanted my alien to have a moving gun turret or something like that, I could create a separate gun turret object that would be a parent of the alien. And you could create like these incredibly complicated objects in Unity that have nested hierarchies and multiple scripts and multiple behaviors attached to them. So what I want to do is, instead of me copying and pasting this object 50 times onto my screen, I want to be able to instantiate it easily, programmatically. And we're not going to instantiate things programmatically with the alien, but we will with a bullet. So you'll see kind of the difference. But one of the things that I want to do, I want to make my alien object reusable with all of its properties, with the script that we created for it, with everything essentially. And I want all of them to behave the same way. So basically, if I create 10 copies of the alien, as soon as the player hits any of those copies, it gets destroyed. So watch this carefully. This is magic. So remember with that folder we created called prefabs?
Yeah.
Please select it.
Yes. Yep.
All right. We're going to take alien, and again, watch this very, very carefully. We're going to drag it into the prefabs folder. It turned blue. It's magic. So essentially, just by dragging any type of game object into a file system, we're turning it into a prefab. And what a prefab is, it's essentially a prefabricated, it's a template. So from being a concrete object, it becomes a template. And we can instantiate that template at runtime, we can make multiple copies of it, and we can change its properties at runtime. So what I'm going to do here is I'm going to create a subfolder. And to create a subfolder, I'm going to right-click on level and game object create empty. So essentially an empty game object, it's a game object that doesn't contain anything. And sometimes they're used for organizational purposes, just to kind of like folders. So I'm going to create an empty game object, and I'm going to call it aliens, plural. One of the things that happened, if you notice, I created it and it placed that object in the middle, like somewhere in a weird position. So look at the little gear icon in the corner of the screen. If I click on that and hit reset, it'll reset the position of my game object to all zeros. So all I'm doing is I'm using this as a placeholder. So I'm going to take my alien object and drag it into the aliens folder, essentially. So you'll see that now they will have a hierarchical relationship like this. And what I'm going to do then is I'm just going to duplicate it. So I'm going to right-click on alien, copy, and then I can just keep hitting Control-V or Command-V, paste. So it created alien 1. I'm going to change its X position. So now I have two aliens next to each other. Another Control-V, drag it out. And I'm going to make 5 of these. And watch what happens. Because they're all prefabs, they have the same behaviors. By simply dragging them to the side, essentially all I did, I changed their X property. So if you look at the position between them, the only thing that changes is the X property. So that's the initial position of my object. So if I play my game now, you will see that all of them exhibit the same behavior. It's beautiful. So I can basically highlight all of them and create more copies and drag all of them and create a second row. And now the bottom row has both X and Y offset. So all I did, it's the exact same class that essentially instantiated as a different object. So now I have my aliens moving behavior. So I'll let everybody catch up. And after everybody's caught up, we're going to do the final piece. We're going to do the firing, or the bullet. I'm going to take this last sprite, and we're going to drag it into our hierarchy. So you can see that it's like this tiny little speck that ended up being added on the screen. We're going to rename it so that it has a capital B. We're going to put a trigger on it. So I'm going to, as we did once before, I'm going to click Add Component, Physics 2D, and Box Collider 2D. And make sure that when you add the Box Collider to bullet, you enable it, set it as trigger. Also, just so that we could see a little better what's happening. So with my bullet highlighted, I'm going to hit F here. That was a bad idea. And I'm going to move my bullet down on the screen. Just so we could kind of see its motion. Okay. So now that I have my bullet, let's get the bullet to move. And the movement of the bullet is actually going to be very, very similar to the movement of the alien. It's just, all it's going to do is going to move along y-axis. All right. So I'm going to go to Add Component with bullet selected, New Script, and name the script Bullet Behavior. And create an add. Once again, it puts it at the root of assets. So I'm just going to take it and drag it into scripts so that everything is organized. And then bullet behavior, we're going to open it. So we need to do two things with a bullet. The first thing is we need to get it to move. The second thing we need to do is to detect when a bullet hits the alien. Let's start with motion. So I'm gonna create, excuse me, we don't need update here, so I'm gonna delete it. And I'm gonna create a function called move bullet. And just like with move alien, we're gonna find the current position of our object. So vector3 position equals game object dot transform dot position. The new position is going to be vector3 new position equals new vector3. And one thing that I forgot to do, we're gonna, again, just so that we could figure out by how much to move it, and remember the bullet needs to have a little bit of a jerky motion. I'm gonna create a public float variable. I'm gonna call it move by, and I'm gonna initialize it to something like this. So 1/1000th of a unit, so that it's smooth motion, but at the same time we see a little bit of a jerkiness. So then new vector3, and in the new position, essentially we're capturing the x of the original position. We're incrementing the y position by move by, and z doesn't matter, so we're just going to leave it at 0. And the last step is game object dot transform dot position equals to new position. Last, in start, we're going to invoke repeating one more time. So this is the exact same thing that we did with alien controller. We're just basically enforcing vertical motion instead of horizontal motion. I'm calling move bullet. And we're going to call it every like 100th of a second. I'll bring this back up so you could finish copying it, but I just want to show you what it would look like. So watch the bullet very carefully. It's a tiny bullet. So it's moving very slowly. Not very useful. So we want to move it a little faster, which is again the reason why we made this variable a public. So I'll change it to 0.01 instead. And now it's moving at a slightly more reasonable pace. Still not great. So I wanted to move a little faster. So maybe, I don't know, 0.0. No, let's try 0.1 and see how. Now it's too fast. Although, still, I mean, I don't know. What do you guys think? All right, that's pretty reasonable. All right, so cool. Now that our bullet is moving, we're gonna add one more piece of sort of like semi-intelligence to this. And this is gonna be logic that's very similar to what we did with aliens and players colliding. So again, we're gonna call on trigger enter 2D. And the logic here is gonna be very, very simple. So if collision dot game object dot tag equals alien, that means we actually hit alien, and we need to destroy the alien, but also we need to destroy bullet, because as we're gonna shoot, we're gonna create many bullets, and if we don't destroy them, they're gonna basically just accumulate in memory. And I mean, with modern computers, it's pretty tough to generate enough bullets to actually crash your computer, but it's still a good programming habit to get into because, well, you know, at some point you might want to generate more complicated objects, and if you accidentally spawn like 5 million enemies without actually cleaning up after yourself, bad things will happen. So we'll also allow the bullet to destroy itself. I will give you guys a couple of minutes to catch up, but just to show you what happens. So I'm gonna run the game, watch the bullet. So it destroyed the alien and it destroyed itself. So I'll let you guys catch up on this. once you guys catch up with this, you literally have 3 lines of code. Well, not so. I kind of lied. Sorry. Well, actually, yeah, we only need about 3 lines of code to actually finish the game. Not too bad. We have really good turnout. Ladies and gentlemen, let me introduce Dylan. Dylan is one of the winners of last year's Games for Health. And he's been working on a number of games in my lab. Okay, is everyone caught up with the code? No? All right. We're gonna open our prefabs folder. We're gonna take our bullet and we're gonna drag it into the prefabs folder. So we're gonna create essentially a prefab called bullet, and then we're gonna delete it completely from the hierarchy. So what we're going to end up doing is we're going to generate bullets programmatically. Now that we have our prefab, we no longer need the physical objects sitting in the hierarchy. We're going to add them at runtime whenever the user presses a space bar to shoot. So one of the key things to kind of remember is we want the bullets to appear on the screen relative to the position of the spaceship. So basically, as we're moving the spaceship, if the spaceship is here, we want the bullet to show up in an appropriate location. So instead of me doing a lot of math trying to figure out where that should be, I'm going to show you a quick trick. So I'm going to right-click here, or actually not right-click, I'm sorry. I'm going to right-click on player, and we're going to add a child object to the player. So I'm going to right-click on player and go to create empty. And you will see that now player has a child object in the hierarchy called game object. I'm going to rename this game object into bullet spawn. And what we're going to do, we're going to hit F, because bullet spawn got placed, I don't know where it got placed, but not where we want it to be placed. So what we're going to do is we're going to, with bullet spawn selected, click the arrows, and we need to make sure that bullet spawn, instead of being at the center of our spaceship, is that it's kind of on the nose of the spaceship. So if you look very carefully, you can see that the 2 arrows intersect on the nose of the spaceship. So because we made bullet spawn a child object of the spaceship, it's essentially physically attached to the spaceship at this position. So anytime we move the spaceship, this empty object moves with it. We don't see it, but it's there and it moves with it. So now all we have to do is we need to generate new bullets at that position, at the position of this empty object called bullet spawn. So what we're going to do with bullet spawn selected, we're going to add the last script of the day. We're going to go to add component, new script, and I'm going to call the script bullet spawn behavior or controller. And hit create and add. Again, I'm going to go to the root of assets, grab the script and put it actually in scripts so that everything is nice and neat, and open up bullet spawn in my script editor. So this is another cool thing. So remember what I told you about public variables? When you declare a variable as a public variable, it appears in the inspector, and you can drag things into it. So this is where I want you guys to watch very carefully. So I'm going to create a public variable of type game object. and I'm gonna call it bullet. Because I made it public, when I go back to my inspector, and this is where you guys really need to watch, if I select bullet spawn in a hierarchy, I'm going to zoom in so you could see. Now I can see bullet appearing here as a property. Right now it's set to none because I haven't initialized it. So what I'm going to do is I'm going to go into my prefabs folder, and this is where you guys need to watch. I'm going to take the bullet prefab and just drag and drop it into this property. And what that does, it essentially links the bullet prefab, which is essentially a class, to this variable. So anytime the bullet spawn controller class gets instantiated, that public variable automatically gets set to an instance of a prefab. So now the prefab is linked to this public variable.
Is this like a constructor?
Yep. Yep. That's exactly what it is. So if I go back to my script, I can now reference this bullet thing, and I'm going to reference it in update. So what I'm going to do here is I'm going to say if input dot get key code dot space. So basically I want to capture whenever the user presses the space bar. I'm going to instantiate. This is another function that's available to you. And I'm going to instantiate bullet. And I'm going to instantiate it at gameObject.transform.position. So remember, gameObject is the object to which the script is attached. And that's that empty game object that I created that's attached to the spaceship. So its position always corresponds to the position of the spaceship. So by attaching this script to a game object that's attached to the player, I can always make sure that the bullets are instantiated in the right position. And then the second parameter that I need to pass is gameObject.transform.rotation. So essentially the position and the rotation of the bullet always match the position and rotation of the game object. All right, so I'll go back to the code in a second, but let's test this. It fires multiple bullets at the same time, unfortunately. So I have a bug in there somewhere. Oh, because I put it in the update. So, with the key pressed, it basically, it essentially continuously fires on the update. So here's another thing we're going to do real quick, just to show you. Well, let me actually let you finish this first.
You said that, like, basically, if I have bullets and all those, they just keep, they're there in the environment, right? They just keep going up.
Yeah.
So could you just delete it on like a Y coordinate? Like,
Yeah, you can do that. You can put if game object that transform that position that Y is greater than a particular value, then just destroy the object.
Okay. You can probably limit the range also.
Yeah.
Oh, instead of doing get key, you can do get key down.
Yeah, we can do get key down.
That'll fix that.
Actually,
Yeah, there.
yeah, I had it in there. So instead of getting any position of the key, if we just do get key down, it registers once until you let go of the key. So it'll be more playable. All right, cool. So now that we actually have almost everything that I wanted to show you today, the last piece that I want to show you today is sound, which is super easy to do in Unity. I mean, it can be super hard once you get into 3D sound especially, but for what we need to do, it's really easy. So what we're going to do, and this is also something that I want to show you specifically to as far as prefabs go. So I'm going to select the bullet prefab, and for a few seconds, I'm just going to drag it into my hierarchy. So notice that as soon as I dragged it, I have a couple of buttons that become available to me. So anytime you make a change to a copy of a prefab that's sitting in the hierarchy, if you want to make this change global, basically if you want to apply to all instances or all copies of that prefab, you have to hit apply after you make that change. Otherwise, the change is going to affect only the prefab instance that's sitting in your hierarchy. So now that it's in my hierarchy, what I'm going to do is I'm going to go into my sounds folder and grab the shoot sound and drag it onto my bullet. And as soon as I do that, you can see at the bottom that we got another property available to us, and that's the audio source. So now that we have our audio source set up, I'm going to go and hit apply. And I'm going to delete this bullet from the hierarchy. So now if I go back into prefabs and look at bullet, because I hit apply, now my bullet prefab has an audio source associated with it, which means that every time I fire this bullet, it's going to make a sound. So I'm going to hit this, play it. Kill him. All right, so the last piece that we're going to do, and we're going to stop here because that's kind of a natural starting point for the next workshop. I'm going to add one more object in here, and this object is going to become sort of like the central piece for how you organize your game and how you organize multiple levels. It's going to be an empty game object. I'm adding it to the level, and I'm going to name this object Game Manager. And the reason I want this, I want some kind of parent object that will end up controlling all aspects of the game, like tracking score, blah, blah, blah. But the reason I'm putting it in there right now is because I'm going to go to sounds, and I'm going to grab my background sound, which is the second sound file that I gave you, and I'm going to drag it onto this empty game object. Finally, what I'm going to do once it's attached to the game object, I'm going to go into the properties, into the inspector, and I'm going to set it to loop because I want that sound to play continuously throughout the game to make my game even more annoying. And this is the result. So basically, this is how you make a really crappy version of Space Invaders.